Now let's bring what we found back to graphing solutions of y equals ax squared plus bx plus c, which we can also think of as the function f of x. To graph this quadratic equation, we need to find these important points that we saw: the y-intercept, the x-intercepts, and the vertex. Like with lines, the y-intercept happens when x equals 0. So if x is 0, then y equals a times 0 squared plus b times 0 plus c, which is just c. So we get that the y-intercept happens at the point 0, c. How about the x-intercepts? Also like lines, the x-intercepts happen when y equals 0, because we're along the x-axis and they're not moving up or down at all. If y equals 0, then we get the equation 0 equals ax squared plus bx plus c by substituting y equals 0 in our first equation. We can solve this now using the quadratic formula. To get r1 and r2 are negative b plus or minus the square root of b squared minus 4ac all over 2a. And once we know these two values, r1 and r2, we get that the x-intercepts are r1, 0 and r2, 0, because the x value is either r1 or r2 and the y value is 0. Remember, depending on the discriminant, we either get 0, 1, or 2 real roots, which means that we either get 0, 1, or 2 x-intercepts, one for each of the real roots. Now what about the vertex? The vertex happens at the point hk. But how do we find the values of hk when it's not given in that form? Well, we saw that when we built the quadratic formula, h equals negative b over 2a. We didn't have much use for that then, but now we can use it as a quick way to find h. But what about k? How do we find the k value? Well, once we know that x equals h at this point, we can find k because we can evaluate our function at h, the same way that we would find the y value of any point, not just the vertex. So we get that our vertex is at hk, and we now have a quick way to calculate what hk is. One more thing to keep in mind when we graph a quadratic equation is that the graph is symmetric across the line x equals h, the vertical line going through our vertex. This is called the line of symmetry.